If you're calculating percentage changes by finding the percentage first, then adding it to the original amount, you're using a method that breaks down in IGCSE Paper 4. That two-step approach is slow and makes complex compound mathematics nearly impossible to track. Instead, we scale. Think of any original value, like 210, as the complete whole. That whole is exactly 100%, or 1.0 in decimal form. To increase that value by 40%, you don't calculate the 40% separately. You look at the decimal. 40% adds an extra 0.4 to your 1.0 base. Adding them gives you a multiplier of 1.4. Multiply your 210 by 1.4, and you arrive directly at 294. This single multiplier collapses multiple steps into one operation. It allows you to maintain momentum through multi-stage algebraic word problems without stopping to recalculate your baseline. Let's test this logic against the common failure points. How would you calculate a 3% decrease? 3% is 0.03, not 0.3. Subtracting 0.03 from your 1.0 base gives you a multiplier of 0.97. The logic scales for massive increases too. A 250% increase means adding 2.5 to your original 1.0 base, resulting in a multiplier of 3.5. Internalizing these specific decimal conversions prevents immediate mark deductions and clears the cognitive load needed for higher-tier algebra. Once you use a single multiplier, you can handle compound growth. Compounding is just the process of applying that same multiplier repeatedly over a specific time frame. This gives us the compound growth equation. Future value equals original amount times the multiplier to the power of n, the number of years. For 5,000 pounds growing at 8% for 3 years, it's simple. 5,000 times 1.08 to the power of 3. Using an exponent transforms a tedious year-by-year manual calculation into a single precise keystroke. Now let's look at a complex Paper 4 past paper question. We need to find an unknown annual growth rate where an investment grows from $5,500 to $8,000 over 4 years. Pause the video here. Assign x as your unknown multiplier and set up the algebraic equation. Here is the setup. 5,500 times x to the power of 4 equals 8,000. To isolate x to the fourth, we divide both sides by 5,500. This is where students lose marks. That fraction is a long decimal, and cutting it short is premature rounding. Rounding early to 1.45 skews your answer. You must keep the entire decimal or use the answer key to reach the precise fourth root, 1.098201. High-level mathematics isn't just about using the right formula. It's about preserving data purity until the final step. We have our decimal multiplier of 1.098201. Stripping away the 1.0 baseline leaves us with a percentage growth rate of 9.8201%. However, writing that exact number on the answer line often leads to lost marks. You have to follow the exam board's specific formatting protocols. The front cover of a Cambridge IGCSE paper provides a clear instruction. Give non-exact numerical answers correct to 3 significant figures. Identify the first 3 non-zero digits, 9, 8, and 2. Truncate the rest to leave 9.82%. To summarize, 1. Multipliers are 1 plus or minus the decimal. 2. Never round intermediate calculations. 3. Format your final answer to exactly 3 significant figures. To run diagnostic tests on these methods and work with our 24/7 exam coach, head over to studybuddy.tech. Securing full marks requires the logic of the multiplier and the precision of the exam board's formatting rules.